So welcome back to the video presentations of Taicaan Technologies surface analysis tool BEX. In the screen in front of you, you can see a data set that was loaded in the previous tutorial on this. What this tutorial is going to be covering is actually data sets from other instruments, or non-Taicaan data sets. So we're going to start this by opening some files. Here's the first one. Let's click on the open. Let's find the data set. The first one that I'm going to open is, this is AFM data. The second one I'd like to open is a different data format. So on the screen here, I'm going to have to change this box in the lower corner here to an STL file, which is a standard format for 3D printing, etc. And in this case, I have a data set which has been generated from three-dimensional X-ray system. So this is actually part of a tooth. It's a section of tooth which we're interested in doing some volumetric wear studies on. And you can see this, let's just zoom in. This is just the section of the tooth. Very nice representation here of this tooth. So currently we have an array of data sets. We have the pyramids from the last presentation. We have a range of pyramids, different views of the pyramids. We have the original data set with the pyramid structures on, used previously. We now have some data, which I'll talk to you about in a second. This is AFM data, and then we've loaded data from another instrument, from an X-ray instrument. So let's start by just removing some of these. I can do the same thing as I did previously. I can just highlight this one, then click and just remove all of those. Let's go back, and here they are, just removing them. And we now have the AFM data shown here. So let's just take a look at the AFM data briefly. We'll come back to this in future presentations as an example of looking at roughness characterization. This particular sample, it's in the jet color scale, but this particular sample is a gold-coated carbon nanotube structure measured with an AFM. And if we just take a look at the details of the information here, we can see we have 256 points by 256 points, and the grid spacing is 156 nanometers. So this is AFM information. It's the scale associated with something like a scanning electron microscope image. And if we look at the cross-section here, we can see that the total cross-section runs from 0 to 40 microns. So this sample is 40 microns by 40 microns. If we look at the ceramic part, if you recall, it's in the file name here, 20 millimeters by 20 millimeters with a grid spacing of 20 microns. So this is on a completely different scale. The sample that we're looking at with the AFM would be a very small section of just 2 data points essentially in this scale. And then finally we've got the tooth chip, and you know from experience that this is going to be on the millimeter scale. And if we look at the cross section here, we can see indeed that's correct. It's running from 0 to 5 to nearly 5.5 millimeters. So we now have 3 objects with very different scaling, all presented in the same software in the same color scale. So let's go back to the AFM data. I'm going to change this to the top-down view shown here, and then I'm going to go to the color scale on the right. Let's reduce the size of that a bit, but I'm going to click on contours. And what this has done is it's drawn contours as shown here. I've just moved the slider slightly, but this is now drawing 5,000 contours per millimeter. In other words, 5 contours per micron. And if we just zoom into this, we can see again a very nice artistic image of this particular surface with the contour lines highlighting the spacing there. If I now switch to the pyramid structure, here it is, and if I right click on the contours for this structure, it's actually showing contours at 5 per millimetre. And let's try this finally for the tooth chip. Switch on the contours, and here it is, and these are now set to 10 per millimetre. So each one has a different contour setting, but the images are there. And if we just switch to the top-down view here for the ceramic part, sorry, I've switched too many times. It's quite a large data set, just once more. And here it is. And finally to the AFM data, and again for the tooth chip. Now, just to finish off this presentation, it's the only time I'm going to be showing you STL data or these X-ray data in these BEX tutorials. So what I want to do actually is just show you one fantastic capability here. If I just click on the yellow line, we've seen this before, I'm going to remove the lower part of the surface, and then I'm going to fixate the scale. In doing so, what I essentially do is I change the contained manifold, which was representing the X-ray data, now into basically a surface. And now we can apply the same type of, let me just do that once more, and fixate the scale here. And you can see now I'm just concentrating on the upper part of the surface, and I've got a very nice representation of that surface. So I'm now able to do statistical analysis, I'm able to get parameters from the surface, and this is really something quite exciting, and actually as far as we know, this is unique to the BEX software.